everybody. Cool. So yeah, we're going to talk about ray tracing today. I think in the program it says we're going to focus on the BMW spot. We'll definitely talk about that. Unfortunately, the BMW model itself is like highly classified, so they don't let me carry it around on my laptop in its, uncompiled form. So we'll take a look at another scene, but that's no big deal at all. So anyway, yeah, my name is Mark Schoennagel. You may have saw me in the keynote. I'm the lead evangelist for the Americas, living in Los Angeles. Super happy to be here. Love the city. And I'm not going to blab about that too much. So anyway, couple things. First of all, currently ray tracing is in experimental preview mode. It's buggy. It's going to change probably by the time it's released. In fact, it will as far as how some of the components go. But I'll be able to give you a pretty decent look at some of the functionality and then talk to you a little bit about what ray tracing is good for and some of the things like that. So again, it's for Nvidia RTX right now only. I'm sure AMD is going to release some hardware, and as soon as they do, I'm sure we'll have tools for that as well. This laptop has a RTX 2080 Max Q, whatever that means. It is a pretty fancy laptop. It's fast. It makes the airplane power shut off when I plug it in. It gets super hot, and it's pretty darn awesome other than that. So if you want to do this for yourself, you can download all of the tools right now that I'm going to show you. They're available today on GitHub. Just search for Unity Experimental DXR. The reason it's not RTX is we're running on DirectX, so this is DirectX ray tracing. So before we actually get into anything more, I'm going to go and just close out of this real quick, and I'm going to show you that same thing I showed in the keynote, and just show you, maybe show you a few more things for those of you that may have missed the keynote. Just want to show you what you can do with ray tracing once you make a build. So this project was incredibly insane to work on. We had almost no time to do it, and engineers were going nuts in Paris, Lithuania, Stockholm, Copenhagen, San Francisco, and wherever I was on an airplane that day. To get this done was a real big challenge, so really hats off to the team who put it all together. It takes a little bit to start. We do a little bit of pre-warming, and there's definitely a lot of optimization still to go with ray tracing in Unity. It's very, very early in its infancy. So again, what we saw earlier today are being able to toggle things like real-time ambient occlusion, real-time reflections versus screen space. I mentioned it in the keynote, but just to kind of drive the point home, if you're not familiar with ray tracing, it's very, very different than rasterizing graphics on a GPU the way we do it today. Completely different. Ray tracing is pixel-based. Every single pixel of your frame fires a ray. If you're rendering at 100 by 100, you're going to render whatever that math is. I can't even do 100 times 100. That's how many pixels you're actually going to calculate. The bigger the frame, the more pixels. Every single pixel fires a ray, and I'll explain that more with a slide. It gets very, very expensive as you increase the resolution. Generally, rasterizing game engines today don't suffer the same performance. Doubling the size of the screen in standard rendering isn't the same as doubling it in ray tracing. It's much more expensive to increase your resolution. So the fact that we can do all this is pretty amazing. One thing that's cool to point out too is this is a hybrid ray tracer, which means you can selectively pick what objects are going to either receive or transmit or be involved with ray tracing at all. So something like Battlefield, where they're just doing, say, the water and some of the reflections, they're not ray tracing the whole frame. They're just ray tracing path outwards from the objects that are reflective or refractive or whatever. So you can really kind of optimize what you're trying to do until hardware gets faster and faster and faster until we don't really care about it. Guy from Samsung came to me at the Game Developers Conference and said, "When can I ray trace on my phone?" That'll be a while. It's extremely computational intensive. Crazy dedicated circuits on the Nvidia GPUs to do this. So anyway, what's neat here is, if I can find my mouse, you guys don't see anything. That's my bus. That's hilarious. All right, let me just kill this. I'm in good old PowerPoint put me into whatever mode. So I want to do duplicate. There we go. That's what I tool around in California with. So anyway, now I have to reload all that. Wow, nothing I said made sense then. Well, maybe it did. I should probably look behind me when I do this. All right, so now I have to reload the whole damn thing again. Now I have to babble about what I was babbling. Gosh darn it. All right, well, there's a little green sliver that says the Nvidia thing's doing something. How's your day going? Good. We flew in from Shanghai on the red eye last night. No, day before. Anyway, I'm exhausted. There we go. That's what I was hoping to show. This thing. All right, so back to what I was talking about. Screen space versus ray traced. So the thing that makes ray tracing so compelling and so amazing is the entire world is evaluated. So you fire a ray, it's going to return what it hits, but if it's reflective or refractive or transparent, it's going to continue that ray further on before it returns what that pixel color should be. Very different than using like screen-spaced reflections or screen-spaced tricks. Anything that's screen-spaced, if it's not on this visible frame, you're not going to see the reflection. So if I had a big moon over here or another object with screen space, we would not see that reflection. Ray tracing, we would, because it's going to ask what it is over there. So it evaluates the whole world, even individual or even invisible pixels, which is why we kind of say it's the holy grail, because it really is physically accurate the way the light bounces around. If I turn off, say, my reflections and go back to screen space, the pixels of the side of this wheel, they're not evaluating in screen. They're not visible, so we're not going to see that reflection. If I turn it on in ray tracing, though, we get an entirely different look down here of the reflection of the underside of the car and how that relates, because this pixel here is bouncing up, then bouncing down, and figure out exactly how that works. I've done, my entire career was all doing animation in Softimage, which is like Maya and Max, and that uses ray tracing, Mental Ray, there's RenderMan, there's all these different ray trace renders. Most of them are CPU intensive. You can have a 64-core workstation, and it's not going to render as fast as this little laptop will, which is quite amazing. If we turn on things like ray trace shadows, you can see the contribution there as well. Primary rays, if we go here to the taillight shot, we're able to turn on the secondary bounce, which is what happens here. So we actually had to crank that material color up to look this kind of weird pinkish color when we're doing rasterizing, because otherwise it didn't look right when we ray traced it. So that's just turning on the primary rays, or that first bounce of light into the ray trace. If we go into the interior, we saw some of this earlier. Again, I mentioned in the keynote, this just blew me away how accurate. It actually gets slower when I project too, so it's kind of a bummer. We lose a bit of our frame rate. But this shifter knob with these little refractions here, that's exactly how it looks in the real world. That blew my mind. I did not think we were going to be able to achieve that. Got the final build and went, holy crap, that works. Because it looked like that when I left for my little 4-day vacation. It was amazing what the graphics team was able to do. But just look at how we're seeing stuff here that's not on the screen. Some of these reflections are happening way up here, but it's able to still capture those. Again, just the power of ray tracing versus non-ray tracing. If we kind of pan up here, we'll see that more with reflections. Like so, this stuff here is behind us. You wouldn't see that with screen space. I keep saying that over and over, but it is pretty damn cool to have that. So another thing that's really nice about this project is, nothing is baked. If you're unfamiliar with what baking does, baking allows you to do a lot of tricks, allows you to fake a lot of things. Once you start animating things, that's when light starts bouncing all around. That's when a lot of other engines can fail, or you're just not able to do it. Pretty cool. What else can we do on here? We can change things, go to our lighting mode. And in case this has to pre-warm a bit, okay, there we go. So what we're seeing here is, hopefully I explained it clearly in the keynote, but we assigned white materials to everything. But we also captured what the global illumination contribution would be and isolated that and then rendered it on top of the white material. So all of this red right here is what the contribution to this piece of geometry is when the material is set to this red setting. If I set it to beige or blue, this should be, we would see this basically blue, but we just baked that, captured it just so you could see it, so that's why if you're wondering why that's not blue. But anyway, it would be blue if we didn't set it up the way we did. Anyway, just to kind of explain what's going on there. So cool, that's what's kind of nice about this whole thing. Right now, and I'll talk about it more if we have time at the end, this type of technology is great for something like an installation. I don't know if I'd be throwing a crazy amount of ray tracing at a game today. just because a lot of people don't have the hardware. A lot of people may not have as powerful as a 2080 Ti. But if you're doing something like an installation, if you're going to render out a film, if you're anything like that, totally applicable. And I'll give you some other examples as to when and why you'd want to use that. So anyway, I'm going to go ahead and kill this. Not really, but figuratively there. And let's go back to my slides for just a second. What am I looking for? Down here. And PowerPoint is not my friend. Unity is my friend. There we go. Did we see that? Yep. All right. Cool. So yeah, a little demo. So the video that we saw earlier was done by a company called Light and Shadows. What they do is exclusively automotive, high-end renderings, visualization for automotive. We've worked with them before on a Lexus spot, which you may have seen. And again, you know, they both look real. I thought these little scratches and things were the real car. No, that's the bogus one. That's the ray traced one. You know, same here, really focusing on that gear shifter. It's pretty darn cool. So all of this is enabled with the new high definition rendering pipeline. It actually didn't take the team all that long to incorporate RTX with the APIs that we have inside of HDRP. It's fully extendable. Things like ambient occlusion, they were able to actually add in under a day, believe it or not. So a lot of this custom code, you think it must be mind-boggling. It's not that hard once you understand what's all behind HDRP. So yeah, designed for AAA releases, pre-release, and it is open source. You can download this branch of the scriptable render pipeline right now and see all the source code that we're doing right now to enable RTX, which is pretty awesome. Some of the things that we've seen HDRP used for, this was Book of the Dead. No ray tracing in here, but still pretty darn phenomenal. We've been playing around with turning on ray tracing for this, and it's just amazing just how much more believable this scene looks, and maybe we'll release that one of these days. Same with The Heretic. I think when you see part 2 of The Heretic, you're going to see some really cool visuals with RTX enabled on that. We have some games coming out. This is a game that's coming out, Harold Halibut, and apparently that's going to have some RTX in it, so looking forward to that. So it is being used, and of course, we saw this here. One thing that's important to point out on this next slide here is different rendering modes, deferred versus forward. So we need RTX to support both of these things, both types of rendering. I'm not going to go into what the benefits or try to convince you to use one or the other, but essentially something like Mega City with so many crazy amount of objects, such a ridiculously complex scene, we use deferred rendering. Something like our wind-up demo, really beautiful, crazy shading, materials, hair. That was something we want a little bit better look for, so we use forward rendering in that. But ray tracing sits again on top of that. Just like I was saying, you can isolate or just define what you want to ray trace or not. So ray tracing will work in both forward and deferred rendering, which if you know what that is, that's great. I'll tell you a little about some of the applications. So right now for games, we're going to target 60 to 30 frames per second for a current generation console. I just read yesterday that PS5 is going to support ray tracing, which is great. So we're going to see some more uses for that. So really, for games, again, I wouldn't really try to develop a game today for ray tracing. Wait a year or two. But again, if you're doing other things like, well, here's a couple games that use it, and they use it sparingly, but you can see it really provides a beautiful look. I actually went and bought a 2080 Ti just to play Battlefield because I wanted to, and it's cool. It is pretty. But yeah, it's, not a lot of people can do that. It is a pretty expensive piece of kit right now. So then we get into interactive experiences. So this is something like the BMW spot that we have. So that's something where you have dedicated hardware. It's going to be maybe at a BMW dealership or something like that where you can control the hardware. By all means, throw ray tracing at it because you'll be able to really define what that final frame rate is and make sure it's going to be acceptable for your client. Maybe turn things on or off depending. So anyway, and again, it's a hybrid ray tracer. So just turn on the stuff that you want. Make sure that thing's running at the frame rate you need it to, and you're good to go. Interactive experiences, just kind of what I was mentioning. And then offline content. This is a different use case for ray tracing. So you're rendering a film. Right now, I've been to Pixar. I've been to pretty much most of the studios in the United States, and actually a bunch of them here in Australia as well. And there are huge render farms that crank these scenes out. Most Pixar films are still around an hour per frame, and then a bunch of compositing on top of that. You need to make a change. You want your character to move just a hair over. You've got to re-render all those layers, all that stuff. So ray tracing on CPUs is still a bit of a bugger. The nice thing about using offline content or something that you're going to composite together later is who cares if it takes 1 second to render a frame? That's totally acceptable if you're rendering a film, right? That's a lot better than a day or an hour. You wouldn't want to play a game at 1 frame per second. But for something like a film, turn on all the tricks. Who cares if it's even 5 seconds a frame? It doesn't matter. It's just going to produce that frame. You capture it, send it to Nuke, do your compositing, and there you go. One of the interesting downsides, which we learned from our friends at Pixar, whatever, Pixar, is they do ridiculous stuff. The grains of sand, those are 200,000 polygons for each grain of sand. 200,000 polygons for a friggin' grain of sand. That's why their stuff looks so cool. You would not want to throw that at a GPU. The entire footprint must fit into the RAM on the graphics card, otherwise it's not going to render. So, even though we can render films, we can do all that offline, you do have to still follow a few rules, which is maybe make your grains of sand 50 polygons or 1,000, just not 200. It's absurd. Baymax Dreams, on the other hand, totally applicable. They could easily ray trace all of that and increase that look quite a lot. So some of the interesting ray trace effects that we can do: ambient occlusion, indirect specular, area shadows, recursive rendering, indirect diffuse. And I believe there's a slide that's missing that told me to shut up with my PowerPoint and go back to Unity. So I'm going to do that now because I don't want to show you equations. That's not good. Let's leave for a minute. Let's go away. I'm going to fire up Unity. Where am I at? I'm at slide 19. Yeah, let's close all this up. Let's make sure we're in regular mode. Let's go back to Unity and show you how this all works. Duplicate. Are we seeing what I see? All right, cool. So I mentioned I don't have the BMW model. I'm not going to ray trace this, but I just want to show you just how crazy complicated some of these CAD models are. This is what the BMW, this is a Lexus. This is the Lexus LC500H. These are the types of models that we get in CAD. Everything's geometry. Like, we would never do this in a game. Sorry, my mouse is a little goofy on this table. We would never in a game, make the airbag assembly under, or here, let's grab the Lexus logo. Look, the fasteners that hold the logo to the steering wheel are actual geometry, right? You don't do that in games, but you have to do that in CAD because it's going to physically manufacture this. So the BMW model that we had was exactly like this. Stupidly complicated. It's the actual model that was used to create the car. So that's why they don't kind of let me have it, because it's super top secret. But Lexus was kind enough to do it. So anyway, I just want to show you what these models typically are. And automotive is like, yeah, we want ray tracing, and it's got to be able to ray trace these type of worlds. So anyway, that's the type of complexity that we're going for. And I can try to leave Unity. All right, come on, go away. Anyway, all right, well, that's trying to close. I wasn't expecting that. There we go. I'm going to fire up Unity. And I learned today, about 20 minutes ago, that the new 2.0 of Unity Hub is out. So if you fire up Unity today, if you're not using the Hub, geez, go download the Hub. Just makes your life so much easier when you have 50 different versions installed. So if you go to that GitHub link that I sent you and you download the experimental build of Unity, it's 2019.2 Alpha 5 special sauce version, and you have RTX enabled, an RTX graphics card, you can do what I'm about to do. So what I did is I went new 2019.2 Alpha 5, and it comes up with this right here, DXR HDRP. So I'm not going to do that now because it's going to take about 4 or 5 minutes to build that version. So just pretend I hit create, and we had a great time, and then this happened. And then we loaded up the scene, and time went by quick. Save y'all progress bar time. And the reason that it takes so long is we actually include a demo scene with it. So once you load it up, you will have a blank scene like this, and in just a second, we should see. I wasn't expecting that. Come on. Oh, no, I don't want to wait. Oh, geez. Hey, what's going on here? There we go. Oh, wow, no, that's no buzzkill. Close that up. Nothing to see here. You didn't just see that. Just wipe that away. We want to load Sydney, which was, so what I did is I loaded it up, I made a copy of that scene and quickly started going through some of my steps, but I also made a backup copy of it where I've done nothing. So this is exactly how it loads if you just hit new scene. So just wipe that away. So I'm going to load this scene called Indoors. This is included with the preview version. And so now this should load. Come on. Am I not on power? I am on power. This seems a little sluggish right now. Well, maybe I should have left that one open to begin. Oh, come on. Really? This has never happened. Huh. Well, that kind of stole my thunder now, didn't it? Weird. Oh, there it goes. Good grief. This demo's go terrible. Perfect. So, you know, just hello. Cool. So this is how it loads up. This is exactly how it loads up when you create that new project. And it's just a little demo scene that shows us some of the nifty things that we can do inside of here. So I'm going to hit play, and we will go to full screen mode. And we are live. We are ray tracing right now. So I can do a couple things. I can turn on ambient occlusion. You can see it's not too noticeable. We'll dial up some of those effects in a minute, and we'll see this look a little better. This doesn't do anything until you enable a few functions. Ray trace reflections. Look at the difference between screen spaced versus ray trace. So quite a big difference there. From some different angles, you'll really notice the difference, which I'll show you some different angles in a second. And then here, if we turn on ray trace shadows, this is probably the most apparent and the most coolest one. Look at the shadow on the chair right there. Isn't that awesome? That is something you will not get from normal, good old real-time shadows. And that's fully real-time, which is cool. So let's go ahead and stop that. And I'm going to go, and let's just turn off this UI. We don't need the UI for now. And let's start to mess around here a little bit. So what I'll first do is I'm going to get a game object. I'm just going to get a sphere. I just want to show you how we set up some of these assets. So I've got myself a brand new sphere, which put itself way out there in the middle of nowhere. And let's just bring this big old sphere up here and scale it down a little bit like so. There we go, maybe a little bit more. You didn't see that I had a sphere earlier, did you? Nope, nothing to see. So I'll just put that right about there. And you know, spheres are fun because they really let you see how refraction works and everything. So I got this sphere. We are not ray tracing right now. When you're in the scene view at the moment, by default, it doesn't ray trace the scene view. It only ray traces game mode, game view, like so. Reason for that is performance. You may have a lot of stuff in your scene view that's not in your game view, and you know, you can turn this all on. And where you find some of these settings is if you go to your ray traced environment node there. These are all the different ray tracing features that are currently exposed today. Again, this may change. It may be completely different when this gets released, but my gut says, and after talking to some engineers, it's pretty much going to look like we see here. So here's where we can turn on ray trace reflections, ray trace shadows, basically everything in our scene. And then we also have this guy right there, ray trace scene view. So if I turn that on, now we're ray tracing in the scene view. You can see it had a bit of a change there. So let's go ahead and turn this sphere into something much more exciting looking. So what we'll do here is I'm just going to right click, and I'm going to create a brand new material, and we'll call it RTX. Very clever name. I'm going to select my sphere, and let's just drag and drop. Let's just drop it right on there like so, and make sure this changes to RTX. Takes a sec. As I was mentioning, there's still a lot of optimization that has to happen before this gets released to the wild. So you're going to see some artifacts. You're going to see some issues. But again, we're not even in alpha. We're in full-on experimental mode. Excuse me. So how do I make this now ray trace? This sphere is not being ray traced right now. Again, it's a hybrid renderer. We can tune what does get ray traced and what doesn't. This will contribute if there was a reflective wall there and it was set to ray trace. That will definitely get ray traced, but it won't go backwards, if that makes sense. So what I need to do here is tell it, I want to enable ray tracing, but first I'm going to tell it to be transparent. So first you're going to be transparent. And again, a few optimizations have to happen, so it's going to be a little quicker, well, a lot quicker when we release this. And now I'm going to turn on ray tracing. So now we have this sphere. Didn't change at all the look because it's not transparent, it's not reflective, it's not refractive, so it's going to look the same. But if I start to come over here to say the metallic settings, you get that. True, real-time, non-screen space reflections. One pure dead giveaway right there is look at that. I'm seeing the windows that are right here reflecting in my environment. You would not get that with screen space reflections. You probably wouldn't notice it unless you knew what you were talking about or what you're looking at. But a lot of the fakes that we've been doing as game developers, we don't have to do anymore. It's just going to work. Of course, I can make this smooth and get that thing crazy crisp, razor sharp, just by adjusting the metallicness and the smoothness. I want to make this thing, transparent. So how do I do that? Well, the first thing I'll do is go into my, my base color node, and I'm going to set the transparency to 100%. Doesn't look transparent, Mark. Nope, not yet. I need to set my transparent input just to tell it to be spherical. And there we go. Now we see a true ray traced transparency. What really gets cool is when you do this, and you got to make a sound effect. Because that's just awesome. Isn't that badass? Like, if I could just do that for a while. I did it for a while. I'm not kidding. I was like, seriously? That's crazy. I had a teapot for a while. I thought I'd excite you all with a teapot, but anyway. And then, of course, we can go here, turn back on our metallicness and our smoothness. And now we've got something that's impossible in the real world, but who cares? A metallic with refractions. And if I press play, let's go back to game mode. Oh, let's do one other thing. Let's go back here. Let's select my camera, and I'm just going to align my camera to my current view, align with view, like so. Cool, and let's go back to game view, press play, and we should see our animation running on there. What's my frame rate? What are we running at? Come on, stay up. We are running at 10 frames a second. Woo! All right, if I unplug, that's usually around 20, 25, but we are full screen, right? Full screen, 1080p. As I mentioned, every pixel is going to fire a ray. And something like this, there's a lot of querying going around to what's going to make that look the way it does. So again, this would be great for maybe a little bigger machine. Otherwise, I'd tone down some things, set some of my settings up a little bit different. So let's go ahead and stop that. Cool. And let's go into our ray tracing environment settings again. So a lot of neat things that we can set up here. And let's go to my scene view and just kind of change. That's just awesome. Sorry, I'm geeking out. If we go here and let's set our material, let's get rid of that refraction really quick, like so, like that. See this little clear water bottle right back there? Ray tracing it's all about optimizing your scene in some aspects, because you could have one pixel take hours to render if you tell it to have a 500-mile ray length and you want 50 bounces. If you've ever had to take two mirrors and you face them together, it's just that infinite bounce. That's the real world. If you do that in ray tracing and you set it to 1,000 bounces, you'd see 1,000 iterations of that mirror, but it would take forever to render. So maybe you set that at like 3 or 4 each time that ray is going to bounce. And I'll show you a little slide if I have time that makes a little more sense about that. But if we go down here to our ray tracing length, I can start to change. Okay, there's a length of 0. I can start to dial in the length that I want those rays to go. And at some point, we don't see it. If I move my, I have the sphere a little bit too close to the camera. I was going to show you that water bottle would turn black at some point if the ray wasn't long enough. So the ray would fire through the sphere, but it wouldn't quite reach the water bottle, so it'd be black. By adjusting that, and I don't want to change it, I'll just tell you what would have happened. You can kind of see it right there. Yeah, it gets more transparent. There you go. So just increasing that maximum ray depth. And then the ray length here is going to also give us some contributions. So the depth versus the length. Well, that's what I was going to do. Geez, that's why I was doing it. Right, so if we set that to there, now we should see it go from black to transparent, like so. So there's a lot of tuning you can do to get this to look exactly the way you want. It's all based on performance, what exactly you're looking for with that. And there's a whole bunch of other stuff we can control here. Here's our maximum reflection ray length, so some of the same things we had there. Stuff like distances, ambient occlusion. You can see a little bit of ambient occlusion going on there. Oop, wrong one. There we go. Turn on ambient occlusion. And I turned off scene view, so we're going to get a little jitter for a sec. Oh, don't do that. Let's go back here. Come on. Be nice. Oh, turn that on, Mark. Duh. All right, cool. Turn ray trace occlusions back on. Watch this. Let's go, let's see. Let's do this. Let's spin the camera around real quick. And let's get it to sort of where we were before. I want to see if I can see those shadows still. I was going to do this before I mess with the camera. Maybe something like that. Some really neat debug modes that we have in here. So watch this. If I go into, what am I looking for? Under Window, let's go to Analysis, Render pipeline debug. Oh, I had it docked, whatever. Let's go to lighting, and under here, we have this guy right there. This is gonna let us do some ray trace debugging. Let's see what just our ambient occlusion contribution is gonna be. Boom, there's our ambient occlusion contribution. So if I were to start messing with some of the ambient occlusion settings, I can change the number of samples and also change the ray length for ambient occlusion. You would never get this kind of detail with a rasterizer. Not close. Crank that up. So it's a bit costly as far as frame rate and everything goes, but you can see you get some pretty cool results. And being able to use these debugging modes, it's really powerful, and it's fun just to, again, geek out on. What's it doing? Let's see what all of our screen space reflections are doing. So that's the screen space reflection contribution, because again, it's hybrid. I can turn screen space on, or I can turn ray tracing on. Let's see, what else is another good one on here? The depth pyramids, kind of show us some depth stuff. The light cluster, the more lights you have is showing you how far and what the lighting contribution is for a bounce. So the more oranger a color gets, it's gonna start off yellow and get more orange, and then it's finally red. That's telling you that you've used probably too many bounces, you can optimize your scene. So some nice stuff there. And then primary visibility. The only objects, whoop, come on, come back. Why that worked before? I always like the way I get the prototype stuff to show. Oh no. Did I zoom out? No. Wait. That's strange. There we go. So now what we're seeing are just the primary visibility, just the things that are being ray traced in the scene as far as receiving. So you can, again, if you made a mistake, you're wondering why is my frame rate so slow, turn on these debugging modes, see exactly what's being ray traced there. So that's a little bit on how you set this stuff up. We could go into some of the more, some of these more settings, but download it yourself, have some fun. There's a lot of stuff you can do there. So just have, I don't know, about 10, 15 minutes left. So I'm gonna talk to you a little bit more with good old PowerPoint and show you some of the other stuff we have going here. So oh, no, that was something else. This guy. I swear, I've got 3 Unites in a developer day. We went to Shanghai here. Tomorrow we're going to Bangkok, and then it's off to Seoul. And at each one, I have different keynotes and different presentations at all of them. Whew, it's hard to keep all this stuff straight. So where were we? We were somewhere around here. Cool. So let's go slideshow from this slide. That's the equation for ambient occlusion. I'm glad I'm more on the art side because I don't know what that means. Someone sent it to me, he's like, hey, show that algorithm. All right, cool. The neat thing is that's kind of what we get with screen space ambient occlusion. It's good, it's great for a game, it's gonna make your game look a little bit better. It's, we all use ambient occlusion, or you should, but it's not super accurate well, it's not ray traced ambient occlusion like I just showed you. So quite a big difference between, things like rasterized ambient, screen space ambient occlusion versus rasterized. Things like reflection probes. So, traditionally we'd use a reflection probe. We would see something like that. It looks good. It's pretty convincing. Turn on, what is that, screen space reflections? Yep, so there we got screen space reflections on, and we can start to see a little more detail in there. Now we're gonna add indirect lighting with a planar reflection probe. So, I can't remember exactly what version it was, but about a year ago we came out with a planar reflection probe, which is mostly for architecture. You have your shiny floors. Spherical-based reflection probes don't do that very well. So one of the nice things that with Unity entering things like the architecture, vertical, and automotive verticals, we have dedicated teams that build tools just for those people. So planar reflection probe probably wouldn't be around for another year or two if it wasn't for our commitment to architecture. So you can see what that does there. And then ray traced indirect specular kind of gives us an even more beautiful look. That's it. That's kind of the holy grail. Looks really nice. Things like shadow maps, that's not a very good shadow. We start to introduce ray tracing, and we get a little bit better. And then we implemented a paper. I didn't implement it. One of the engineers, obviously, who's much smarter than I did, implemented a paper which gives us just these incredible new, beautiful shadows that we have inside of the RTX version of Unity. Let's see. Last thing I want to show you, recursive rendering. So this is path tracing. This is how this frame was rendered in V-Ray. If you don't know V-Ray, it's a CPU or GPU-based rendering engine. I think it's actually a hybrid. It renders beautiful. It's like Mental Ray. It's like Arnold or RenderMan, whatever ray tracer you might be familiar with. It gives you photorealistic looking images. Takes a while to render each frame because it's sending rays all over the place. So what kind of goes on behind the scene is this is our headlight. If we kind of made it a little bit thicker just to explain how this works, we have our camera sitting. Can you see my mouse? Oh, you can't see my mouse. Whatever. Can you see my mouse? No, you can't see my mouse. All right, maybe you can't see my, whatever. Now? Nope. Whatever. So, all right, we have our camera. We're going to fire a ray. So this is how basically a traditional ray tracer with one bounce is going to render that. It's going to hit the glass. Yep. A bit of it's going to be transported through, and then the rest of it is going to be bounced off, and it's going to finally return us a color value. The more reflective, the more refractive, the more things that are going on in our scene, you start getting more bounces like that before it renders the final pixel, which is that right there. But really, that's about what one trace looks like to get a really good quality image. That's a lot of work per pixel, right? That's what makes ray tracing so computational intensive, is you just got rays bouncing everywhere. Even like inside there, it's just nuts, right, to get a good look. So like, all right, let's throw this at Unity and see what happens. Oh, that looks like crap. All right, yeah, a little disappointing. So we started to turn some things on. So let's turn on screen space reflections. We talked about that a little bit. That's where it's going to evaluate just the stuff in the scene. It's not going to take account what's behind that glass because it doesn't know it's there. It can't see it. So now we turn on recursive ray tracing, and we see something that looks like that, which, you know, that's it, right? That makes this look just as good as V-Ray. We're doing the path trace. We're calculating all those rays bounce all over the place, and we get that, which is pretty cool. And I think I opened the wrong deck because that was my last slide. It was supposed to be one that said thank you. But I see I've got 3 more slides, so let's not talk about those. Anyway, all right, I finished a little bit early. Anyone got any questions? Otherwise, go grab some lunch. Cool. Download ray tracing. Download the RTX version, or you know, if you saw the link, I'll put it up one more time for those of you that just came in. Wrong thing to click on. Here, if you're interested, you just can't see what I'm seeing. I love PowerPoint. It's my favorite thing in the world. There it is. Just do a search for experimental DXR, download those tools, get yourself an Nvidia GPU, and you can do this yourself. So thank you all very much, and enjoy the rest of Unite.